All right, in this video, I'm going to be talking about sections 4.1 and 4.2 of the textbook. This is all about radian and degree measurements and the unit circle. So in this video, I'll do a couple examples, and hopefully they'll be helpful for the homework problems. So first off, here's a question that has to deal with coterminal angles. So say I'm given an angle theta equals 7 pi over 3. That's clearly in radians because it has some multiple of pi, right? So, or some number times pi, right? So the first thing I like to do is determine where this angle lies in the xy plane. So you should always remember that the four poles, right, correspond to different radian measurements. The north pole is essentially 90 degrees, or pi over 2 radians. The negative x-axis, that would be 180 degrees, or pi radians. Down here we have 3 pi over 2, and the positive x-axis is either 0 degrees or 2 pi degrees. So the question is, right, where does 7 pi over 3 lie in conjunction to these four angles? Well, I like to take 7 pi over 3, right, and write it as, to pull out how many full rotations there are in this number. So 7 pi over 3 can be written as 2 and 1/3, right, pi. Or you can think of this as, right, 2 pi plus 1/3 of a pi. Correct. So 7/3 pi can be decomposed into one revolution plus an extra third pi revolution. Angle. So to map this out, we can say, okay, there's my 2 pi, right? That's one revolution. Then it has to go a little bit more. So we're in the first quadrant. So this is the angle 7 pi over 3. Now, a coterminal angle is another angle, right, that lands me at the same spot, essentially. So we can see that right here, just if I go from there to there, right, that would be a coterminal angle. Or another one that we can do is to take the angle that I already have and just do one more revolution off of that. So that would be another one. So something like this. So take the blue angle, which is the angle that I started with, and add 2 pi, or we can take the angle that I started with and subtract 2 pi. So anytime I'm asking you to find two coterminal angles, right, you take the original angle, right, and you can subtract off a revolution, or I can take the original angle and add a revolution. So what I've mapped out here is, right, there's the orange angle. It would be a revolution plus what I already had. And the pink one is just the original angle subtracted off full revolution. So here, if you do this little subtraction here, I have to get a common denominator. So 2 pi is the same as 6 pi over 3, so I'm left with pi over 3. Right, so that's the pink angle right there. And this would be 7 pi over 3 plus 6 pi over 3. So there I get 13 pi over 3. Right, so this guy is the orange one, and this one is the pink one. All right. Another question I could ask is something like, find the complement and supplement to any given angle, say 4 pi over 9. So again, it's always a good exercise to determine, right, where this angle is. Well, 4 over 9, if you actually, so let's think, 4 pi over 9, that's 4/9 pi. Right, so look, 4/9, you can either check in your calculator if you want, 4 divided by 9. That's 0.4444, so that's just below 1/2 pi. So this is less than 1/2 pi. So it must be in the first quadrant. So 4 pi over 9 must be somewhere about right here. It's almost to 90 degrees, or pi over 2. So I'll use the orange marker to represent the complement. So the complement is what's the angle I need to fill the rest of this out to get to pi over 2. The supplement, right, is how much more do I need to go to fill out a single pi, so to get to 180 degrees. So the quick way to do this is just to take pi over 2 for the complement, right, that's 90 degrees, or 1 quadrant, right, and subtract off my angle, 4 pi over 9. So in order to do this, again, I need a common denominator. The common denominator is 18. So I would have 9 pi over 18 minus 8 pi over 18. And so my angle, or my complement, is pi over 18. So that would be the orange angle. Furthermore, for the supplement, you take pi and subtract off 4 pi over 9. That gives me the remaining amount that I need to get to pi. So here my common denominator would be 9. So 9 pi over 9 minus 4 pi over 9 gives me 5 pi over 9. So again, that would be the pink angle. Okay, so that's how you find the supplement and the complement. All right, moving on. So there's another thing we can do. We can convert any radian measure to degrees by multiplying by the following. So if I'm in radians, which usually is, it's radians because there's usually a pi next to it, I would try to cancel out that pi by multiplying by the following multiplier. So 180 degrees is equivalent to pi. So here I'm multiplying by 1. So when I do this, the pi's cancel. Essentially, I get 3/4 of 180 degrees. And then you can put this in your calculator, right? 3 times 180 divided by 4. And I get 135 degrees. Right, so 3 pi over 4 is equivalent to 135 degrees. Now this one's a little weird, right? This one, 3 radians. So where might that thing lie? Well, let's think about it. You gotta be careful here because I know that, right, this is pi over 2, and this is pi, right? This is 3 pi over 2. Remember, pi is just a number. It's close to 3.14. So what is the actual value, maybe the decimal approximation of pi divided by 2? Well, that's about 1.57, right? This is about 3.14. And 3 times pi divided by 2, that's about 4.71. So where is 3 radians? Well, it's bigger than 1.57, so I plow through that, but it's not quite the size, right, of 3.14. So it might be about right there, right? It's not long enough to get me to 3.14. So it's just before 1/2 revolution. But in any case, I can still use the same multiplier. So I'll take 3 and multiply it by 180 over pi. And if you put this in your calculator, let's see what you get. You get 171.89 degrees. So that's pretty close to 1/2 revolution. Likewise, I can convert anything that's in degrees to radians by the following. So I take 420, negative 420, and I can multiply that by not 180 over pi, but pi over 180. That way the degrees cancel out. So if you see this, I can cancel these things out now. So essentially what I have is negative 42 over 18 pi. And what happened there? Well, I canceled the zeros as well. So 42 divided by 18. Let's see, it gives me a decimal, but I'll convert it back. So what do we get there? Negative 7/3 pi. Right. So if you want to orient this thing, what quadrant would this thing lie in? Well, here's 0, here's negative 90 degrees, and I'm doing negative because I'm going the negative direction. This would be negative 180 degrees, negative 270 degrees. This would be negative 360 degrees, plus another 90. This would be negative 450 degrees, and I'll stop there. So if I want to map out where negative 420 is, there's negative 360, and then a little bit more, it's in the 4th quadrant. Okay. All right, so now we can use the unit circle to actually define the trig functions and calculate the 6 trig functions of any angle. So if I'm going to use the unit circle for this, we kind of have to memorize where these angles lie. So on the unit circle, here's the circle of radius 1, right? 1, negative 1, and negative 1. These are the 4 points. 5 pi over 6, again, where does that lie? Well, it's just 1/6 away from being a full pi, so it's in the 2nd quadrant. It's probably somewhere here. So if I look at the point that corresponds to the angle 5 pi over 6 on my unit circle, I get the point negative root 3 over 2 and positive 1/2. Right? So this is the coordinate, right? XY that corresponds to that point. X is negative root 3 over 2, Y is positive 1 over 2. So that means I know exactly that cosine of 5 pi over 6, right, is equal to negative root 3 over 2. And sine of 5 pi over 6 is equal to 1/2. Now, how would I find the other ones? Well, tangent of 5 pi over 6, that's defined as the ratio of the y-coordinate to the x-coordinate. So I would take the y-coordinate, which is 1/2, and divide by the x-coordinate, which is negative root 3 over 2. The 2's cancel, leaving me with negative 1 over root 3, or if you want to rationalize it, you get negative root 3 over 3. So that would be the tangent. Now the other three kind of come along in the wash, right? They're just the reciprocals. So secant of 5 pi over 6, that would be just a flip of that, so 2 over root 3. Cosecant of 5 pi over 6, right? That's the flip of sine, which would be 2. And finally, cotangent of 5 pi over 6. Looking at this version right here, that would give me negative root 3. So those are my 6 trig functions of that angle using the unit circle. Okay, let's do something similar. What about this one? Negative 15 pi over 2. Now, where does this thing lie on the unit circle? Well, again, this is a negative angle, so I might try to orient myself this way. Let's first rewrite this as a mixed fraction. So negative 15 over 2 pi, right? Let's take out the main part, so that would be negative 14 over 2 pi minus another pi over 2, right? So negative 14 minus 1 would give me negative 15. So this is negative 7 pi. And then another half of pi I have to go. So let's think about this. Where was negative 7 pi? Well, that's negative 2 pi right there. If I go another one, that would be negative 4 pi. Negative 4 pi. And if I go another one, that would be negative 6 pi. All right, so I got negative 6. And then here would be negative 7 pi. That would land me there. And now I have another 1/2 to go, which puts me right there. So if you think about it, right, I need to know a coterminal angle, right, and this is the most simple one. Essentially, these two things are coterminal because they land me at the same point on the unit circle. So instead of going negative 15 pi over 2, I could have just gone pi over 2 in the positive direction. In any case, right, I landed at the point 0, 1 on the unit circle. Right, so if you think about it, cosine of negative 15 pi over 2, that's equal to cosine of pi over 2. Why? Well, these two things are coterminal. Right, so doing the trig function of those two angles gives me the same number. And so here I take the x-coordinate and it would be 0. So sine of negative 15 pi over 2 is the same as sine of pi over 2, which is 1. And now the other ones follow. So tangent of negative 15 pi over 2, right? That would just be equal to y over x, which is 1 over 0. Uh-oh, that doesn't exist. So the value of tangent at that point actually doesn't exist. So I'll write dne for does not exist because I can't divide by 0. Now, what would be the other ones? So I can do secant, right, of negative 15 pi over 2. That would be 1 over 0, which again doesn't exist. I can do cosecant of negative 15 pi over 2. That would be 1 over 1, which is still just 1. So I did the reciprocal of sine. And cotangent of negative 15 pi over 2, right? That's x over y, which would be 0 over 1, which is just 0. Okay, so the main point here is, right, I could have this very complicated angle, but in reality, it's just going to land me somewhere else on the unit circle, and I can still use the same points as before. All right, let's try one more. So evaluate the 6 trig functions of the angle negative 9 pi over 4. So again, let's think about where this thing is. So negative 9 over 4. I'm going to take out the negative 8, so that's negative 8 over 4, plus another negative pi over 4. So this is negative 2 pi minus 1/4 pi. So I got to go negative 2, which is 1 revolution, and then an extra negative 1/4. So again, I start here. That's negative 2 pi, and then an extra 1/4 lands me here. So the coterminal angle on the unit circle, so here's the unit circle, right? What's the point that corresponds to that? Well, let's think about it. The actual point or angle that's on the unit circle would be going from here to here. So if you look up your unit circle, that would be the angle 7 pi over 4, right? So 7 pi over 4 and the original angle are coterminal. So if I look up that angle, it would give me root 2 over 2 and negative root 2 over 2, which means sine of negative 9 pi over 4 would be the y-coordinate, cosine negative pi over 4 would be the x-coordinate, tangent of negative pi over 4 would be the y-coordinate, which is negative root 2 over 2, divided by the x-coordinate, which is just 1 because they're the same. Negative 1. Cosecant of negative 9 pi over 4. Flipping sine would be negative 2 over root 2. And let's see, which is just negative root 2, by the way. Secant of negative pi over 4. Flipping cosine would be positive 2 over root 2, which is just root 2. And finally, cotangent of negative 9 pi over 4, right, is the flip of that. So 1 over negative 1 is negative 1. So those are my answers. Okay, so the moral of the story here is you kind of have to find the coterminal angle on the unit circle that still points to that same point, right? And then there you go.